Hello engineers, welcome to another video on low-level design. In this video, we're going to tackle the final creational pattern, which is the prototype pattern. I hope you're ready. Let's get started. So let's first start with the intent. This is the intent for the prototype pattern. Specify the kinds of objects to create a prototypical instance and create new objects by copying this prototype, right? So there are two pieces here. Specify which one requires a prototypical instance and then create new objects by copying this prototype. So to understand this pattern, we need to understand two things. First thing is, this is object creational. We are no longer talking about class level stuff. We are talking about object level stuff. So create an object first that qualifies to be a prototypical instance. So make an object so meaningful that it makes sense for it to be cloned or for it to be copied so that it can be used as a new object, right? And this clone can happen multiple times, right? So by creating one object and making it so meaningful and powerful, we can leverage this object. Whatever are the properties of the object, whatever are the methods of the object, we can leverage that so that we don't have to go through the object creation process again and again for the remaining objects. We can do something called cloning, or we can do something called copying, right? So this type of pattern, this type of usage is called the prototype pattern, right? So let's see where this might be very useful to us. So the first example are editors, just like this Microsoft OneNote. There can be many editors like this, right? And wherever you see this option, right? For example, if I want to copy this page to some other page, what will happen? So when I click copy, not only is the new page getting created on the other side, but it is also copying this header, it is copying this bulleted list, it is copying this intent, it is copying all the diagrams that I have drawn and then creating a new page there and pasting everything there, right? It is exactly like cloning, and they are independent of each other. It's not like if I change something here, the other page will automatically get changed, right? So there is a deep copy happening here, which means that there is an independent object created with its own memory, with its own storage, and it is living as its own. But during creation, it is making use of this page as the prototype or the template and then copying everything into the new space, right? So wherever you can see this type of structure, you can imagine that there is some form of prototype pattern being used. And another example is templates. So there are many applications where templates are used, right? For example, if I go to Google Docs, and if I want to create a blank document, I get a blank document. But if I want to build a resume, or if I want to build a project proposal or anything like that, right? So I can make use of this template. And what happens here? The entire content of that template is getting copied to my new document, and all the things that are part of the template are pasted here. So that from here on, I can make use of the template. So by altering my name here, it is not altering the template itself, but this page, this document is living on its own. So this is one of the excellent use cases of prototype pattern. So we make something meaningful, like the template we just saw, right? The resume is a meaningful template. It has all the title, bullets, and everything structured neatly together. So it qualifies as a prototype, and I can use this prototype to continuously make copies of it so that I can build my own stuff, right? So that is another good example of the prototype pattern. And the third example is quite interesting. When we see games like Warcraft or Age of Empires, right? So we are building armies, and armies are fighting against each other. And as we progress in the game, we kind of multiply the armies that we have, and we build on bigger armies. And during this multiplication, you will notice that the same block of soldiers will continuously get replicated again and again, and they all fight together, right? So this replication of army soldiers is an excellent usage of prototype pattern, because every time we don't have to create one soldier at a time, but we can directly clone an entire army and make use of it in the game, right? So this is something we'll try to build today. This will be interesting. So this is another example of prototype pattern, right? So the summary is make something so meaningful that it can qualify as a prototype and just make copies of it and use them, right? That's the whole idea behind prototype pattern. So before we move on to the implementation details, let's try to understand the difference between a shallow copy and deep copy. So in shallow copy, what happens is when you try to copy a pointer to another pointer, or when you try to make a reference from one pointer to another, we will get both pointers referring to the same memory address. They are not referring to two different things. So if I change something using ptr1 in an object, automatically ptr2 is also affected because they are both referring to the same object in the memory space. So this is shallow copy. This is not what we want in our prototype pattern. We need a deep copy, which means that once I have object 1 and if I want to create object 2, then object 2 should have its own memory, should have its own life cycle and so on. And whatever change I'm making to object 2 should not affect object 1. So object 1 should be the prototype on its own, and object 2 will be just a copy of the prototype and I can make any changes to it, right? So this is the difference between shallow and deep copy. And in prototype pattern, we always use deep copy. Okay. So with that clear, let's move on to the implementation details. Let's look at the UML diagrams now. So in the creational folder, we now have a new friend, prototype pattern, and let's look at the class diagram for it. So this is how the prototype pattern is implemented. So we have a common interface with a mandatory method called clone. Okay, and whoever is implementing this interface will have to implement the clone method, which means that first you define the template. For example, in our Google Docs example, we saw the resume template, right? So when you build a resume template, automatically allow a clone method inside it so that whoever wants to use that resume template can just call this clone method and they will get their own document. Similarly, I can build upon a project proposal template. I can build upon a school report template and so on. And every template will implement a clone method, and that clone method will return a copy of itself. And this is not just a simple copy, this will be a deep copy, which means a physically new file or a new object is created and returned. That is a deep copy, right? So this is the whole idea behind the prototype pattern. So let's see the sequence diagram. So first, the client calls upon the concrete prototype, let's say the resume prototype, and creates the resume template, right? After that, the client can call the clone multiple times to create clone prototypes. Like this is the physical document, resume 1, resume 2, and so on, right? So the resume template is created once, but the cloning can happen multiple times. And each time a new copied instance is created, right? So whenever a clone is called, a new deep copy of self is created and that is returned to the client. And the client can now perform all types of operations on the clone prototype, right? So simple implementation. So let's try to create a game army just to keep things interesting. So let's see how we can use a prototype pattern in this. So on the left side, we have the soldier interface. So this is the army soldier in our video game. And there can be two types. There can be a basic soldier and there can be an advanced soldier. So basic soldier has experience, weapons and health, while the advanced soldier has all these, and additionally the soldier also has armor, right? And as you can see, both the basic soldier and the advanced soldier are implementing the clone method, right? And what will this clone method do? It will create a copy, deep copy of the basic soldier and return it. And the advanced soldier will create a deep copy of advanced soldier and return it, right? So by using the basic soldier as a prototype, I can create any number of basic soldiers just by using the clone method. I will define the basic soldier once using the standard experience, health as 100, and give some basic weapons and stuff. And I can recreate the basic soldier again and again by just calling the clone method. So this is a less expensive operation. Imagine if I have to go to some website and do some asynchronous operations and build the basic soldier. That would be very expensive while creating every basic soldier. But once I do that, I don't need to repeat that activity again, and next time I can just clone it, right? So that's the advantage of prototype pattern. And similarly, we have advanced soldier. And we can use this piece to build an army. So if we look at the basic army will have soldiers, which is an array of basic soldiers, right? So army will contain many basic soldiers. advanced army will contain many advanced soldiers, right? And once I build a basic army, I can use the clone method on the army itself and build multiple armies like this. Like in the video games, if you have ever played, if one army of 10 soldiers are fighting and I have upgraded myself to 20, so I will just call upon basic army clone and 20 soldiers will be available on screen for me. And if I call it again, 30 soldiers will be available on screen for me. So by just calling the clone method, I'm not only saving time in building the basic soldiers, but I'm also saving time in building an entire army. So that is where the power of this prototype pattern comes in, right? So we have the army interface, which is having the clone method, and both basic army and advanced army are implementing the clone method, and they will return their respective armies as a clone. Again, here also we follow the deep copy method, right? So this is the diagrammatic implementation of prototype pattern. Now let's see all this in code. So as you might expect, first we have a basic class for soldier, and soldier has one method clone, which is a virtual method here, which will be implemented by the basic soldier and advanced soldier. So what is the basic soldier doing? While implementing the clone, basic soldier is making a unique basic soldier based on this. So what is this? This is having all these private properties. The knife, blade, health 100, experience 100 are belonging to the basic soldier class, and by using make unique we are ensuring that it is a deep copy. So it is calling the copy constructor and making sure that there is a deep copy, and we are returning that object, right? So this is the clone method of basic soldier. Similarly, we have advanced soldier. Advanced soldier is having more weapons, and even in advanced soldier we have the clone method. And this clone method is again using make unique to make a deep copy of an advanced soldier and returning it, right? So these are my pieces on the left side. Now we will repeat the same thing on the right side. So this is the base class for the army. Again, for army we have the clone method, which is virtual here, which will be implemented by basic army and advanced army. So the basic army will carry a vector of soldiers, right? Because there will be multiple soldiers in our army. And when we call upon the clone, it will create a new basic army and add soldiers to it and return the army. So I have shown the implementation of the basic army. If you want to attempt the same implementation of the advanced army, please try to do so. It will be a good practice for you, right? Now let's see the implementation, how we can actually use the prototype pattern. So first we create a basic soldier, right? We are creating a basic soldier and we are adding the soldier to the army. So we created a basic soldier, we created a basic army, and we are adding one soldier at a time to the army. So in this case, we are adding 3 soldiers, but you will realize that we are not doing new soldiers every time like this, but we are just making use of BS1's clone. So when we call upon clone method, we already know that it is creating a deep copy, and that is being returned to the add soldier method, and that is getting added to the vector of army soldiers, right? Similarly, we can repeat this process any number of times, right? So once we have in the entire army, we can call upon the clone method on the army object BA1 and create a BA2, which is an exact clone of the army 1, right? So now we have 2 armies, BA1 and BA2. So you will see that for creating BA2, I have not used any creation of any soldiers. I have just called upon BA1.clone and I got an entire army to be used straight away, right? This is the power of the prototype pattern. And if I want to build a third army, I can just call BA3 equal to BA1.clone, right? So make something meaningful like this BA1, which has a set of army soldiers. So this becomes our template or the prototype. And I can just use this prototype to clone it and create more meaningful stuff out of it, right? So they're just duplicates. So just to show the difference, I'm adding another soldier to the first army. So BA1 will now have 4 soldiers and BA2, as it was cloned, will have the 3 soldiers. And I'm just printing both the armies. So if we run this code, we see that this is the original army, which is having a basic army of soldiers with 4 soldiers. And the cloned army is also a basic army, which is having 3 soldiers, right? So do try and attempt to repeat the same process for advanced soldiers. So it will be a good practice for you. So this code is already available on GitHub. You can directly fork the repo and make changes to it and push it to your own repository, right? So this is the whole implementation idea behind the prototype pattern. Now let's look at some pros and cons. So far we have covered the intent, we have seen many examples, and we have seen the UML diagrams and also the code. Now let's just finally see some trade-offs. So what are the strengths of prototype pattern? As you can already see, complex object creation becomes inexpensive because we are making copies of it. And if the object creation is complex enough, we don't need to redo that complex calculations again and again. We can just make use of copies. So this is the great strength. And we can also see reduced subclassing because by making copies, we are directly using the copies as themselves instead of making subclasses for everything like resume 1 subclass, resume 2 subclass, and so on, right? And this also helps with performance because if we want to dynamically create objects on the fly, we can make use of the prototype pattern and not depend on class creational structures, right? So this is a great advantage of the prototype pattern. Now let's see some weaknesses. So as you can imagine, this pattern would be an overkill for simple objects. For example, if I just want to copy paste a string of text, I don't need to use the prototype pattern for it. I can just create the new text, right, as an individual object. So it is not very expensive to create a single piece of text, right? But if the text contains many things like the font size, italic, underline, bold, and many other properties that text can contain, then that can become a template and which can be reused later on. So whenever you see the possibility of reuse, then make use of the prototype pattern, right? And then because we are abstracting away the object creation by just calling the clone method, we don't know what the clone method is doing internally when there is a large application. And then we don't know what was used for the original object creation. Was there any dependencies with external systems and things like that? That is something we don't know. That is something to keep in mind, right? So these are some of the weaknesses or things to keep in mind while using this pattern. So these are some of the trade-offs. So if you have any other trade-offs, definitely share them in the comments below so that everybody can learn and I can learn as well, right? That's all I had for this video, guys. We have finally covered all the creational patterns. In the next video, we will go into the structural design patterns. So if you have liked this video, definitely leave a like. That will mean a lot to me, and do subscribe if you haven't done already so that you don't miss out on the future upcoming videos. Thank you so much for watching, guys. I will see you in the next one. Cheers.